reason you evaluated 1 over p times square root is just so you could graph it.
Yes, yes, and then I cannot tell you what the points are if I don't determine these y values. I'm only going to tell you at 0.61 there is a local min, but you will ask me how much is it, and then I'll have to plug it in and tell you negative 0.18.
So with questions that don't involve odd numbers like e, we wouldn't have to go. So numbers would just come up in this.
Yes, but there may be some approximations. You may still have to put them in the graphing calculator, though.
I see.
Yeah. And I would like to go back just for a second to the other function, since we have all the information we need. So let's go back and graph the other one, if you'd like. This one. Okay, so this function will be f of x over x squared plus 1. So I have the points negative 1, negative 1/2. I have the point 0, 0. I have to have the point 1, comma 1/2. Obviously the function is even. I'm sorry, odd. Because when you replace x by negative x, you will get the same. So what we graph in the first quadrant, we have to graph in the third quadrant. Because f of negative x is negative f of x. F of negative x is negative f of x. So the function is odd. Okay, so it's coming from approaching 0 because y equals 0, horizontal asymptote. From approaching 0, let me use a different color. From approaching 0, and we did not determine the x-intercept here. So the function will, what will the function do? So it opens, so it decreases. When I look at my table, that's when I know if there is an error or not. So this is the inflection point. Oh, okay, sorry. Yes, okay, so this is the inflection point. The function, it's decreasing and increasing. Increasing. Increasing from negative 1/2 to 0 to 1/2. So it's increasing and opening. Okay, so opening up, increasing to the max, and then it's increasing to the maximum, and then it's decreasing. How can it be decreasing without another inflection point here? So it's increasing. This is okay. It's increasing to a maximum, 1, 1/2. That's okay. It's yes, it is concave down, but it has a horizontal asymptote. Did we forget anything? Positive between that's correct, we checked everything. So the function has to have let me take a look for a second, 1 second. Where was our second derivative? Did I mess up something? Because the function does not, from my table, this is fine, reaches a maximum, but it has to come asymptotically to 0. So there must be another inflection point. It makes no sense. I have to check my second derivative. I have to check my first derivative as well, just to make sure. Now I don't believe anything. So that's correct, minus x, that's correct, times 2x. This is negative 2x squared plus x squared. That's negative x squared. That's correct, that's correct. Okay, now I need to check my second derivative. Where is my second derivative? Right here. It was negative x squared minus 1. Yes. So 2x, that's correct, minus that, correct, times 2, times this, times 2x, that's correct. Over this to the 4th power, that's correct. We kept the minus in front, yes. We factor 2x, we factor this. I'm sorry, I forgot. It makes no sense. Do you understand when I started graphing and I realized that something was wrong? Because the function comes to a maximum, it has to have another inflection point so that it comes back asymptotically towards 0. And the same thing on this side. Because it cannot come like this. It has to turn again. So it asymptotically goes to. I'm so happy I wanted to graph that. I forgot about the 2. Sorry. So we had 2x is out, x squared plus 1 is out. So I have 2 times x squared, negative 2x squared, and plus 2. Sorry about that, I have to correct that. I can't leave it like that. So sorry about that, I forgot about the 2. Okay, so I cannot simplify anymore. See page 10. 10. Okay, so the second derivative is negative 2x, and in parentheses, negative x squared plus 3. That makes a whole difference. Over x squared plus 1 to the 3rd. Negative x, I'm checking again. Negative 2x squared plus x squared, negative x squared. So positive 2 plus 1 is 3, correct. So now when I factor out, I get 2x, x squared minus 3 divided by x squared plus 1 cubed. And there are 3 possibilities, as we already saw. I couldn't graph it. X equals 0, x equals the square root of 3, and x equals negative the square root of 3. So I have to go back to the table and make the correction there. So 0 is fine, the square root of 3, and negative the square root of 3. Exactly as I expected, because I couldn't graph that. So I have to put that in, so we have I have to approximate so I can get this number. So negative the square root of 3, and everything divided by 3 plus 1. Negative 0.43. And this must be 0.43. Okay, so now obviously this will change because this has to open down, and this has to open up, and this is down, and this is up. And now I can finally graph it, and that's the graph, obviously. And this point happens at, this point is another inflection point at the square root of 3 comma 0.43, and negative the square root of 3 this point, comma negative 0.43. See how, my apologies, so this was my error entirely, of course. So how a tiny not that tiny, messed up my chart. So this is indeed a local max, no problem there, local min. But since I know that this is a horizontal asymptote, the function has to approach the asymptote. Yep. Very good. Sorry. Okay. Next problem I would like to look at is something that we will have to build together, or as an example of a function. I think they asked me yesterday to do 25 and 26. Let's choose anything else, so you have 3 examples. So 25 and 26 were done yesterday. If you want 24, 27, 28, 29. Or I will choose.
28.
28, very good. It will take me take a sip of water. I'm kidding. It takes me a while to copy all this. So we have f prime of x greater than 0 if the absolute value of x is less than 2. We have f prime of x less than 0 if the absolute value of x is greater than 2. F prime of 2 equals 0. Limit of f of x as x approaches infinity is 1. F of negative x equals negative f of x. The second derivative is less than 0 if 0 is less than x less than 3, and the second derivative is greater than 0 if x is greater than 3. Okay, a lot of information. We're going to use a table to summarize all this. I can tell what it tells me. Okay, so let's start with the simple part. The limit of f of x as x approaches infinity is 1. So y equals 1 horizontal asymptote at infinity. Done. F prime of 2 is 0. Done. Maybe I should use a different color for that. So these are done. Oops, not good. Okay, this was the easy part. This is telling me that the function is odd. So, like the one that we just looked at, whatever I graph in the first quadrant, I have to have a copy in the third, or vice versa. Whatever I copy or I have in the second, I have to copy in the fourth. Either this way or this way. Okay. So I'm going to write myself a note. Don't forget it's an odd function. That's done. The second derivative is negative between 0 and 3. The second derivative is positive for x greater than 3. Done. So now the last two are these, but first let's discuss the intervals. So I'm going to discuss this interval and then this one. So when we look at the absolute value of x less than 2, we know what this means. If you want me to say more, please do say that. So this changes into this. We're asked to find numbers whose distance from 0 is less than 2, so they have to be between negative 2 and 2. The opposite one, if you'd like, is to the right of 2 and to the left of negative 2, completely separate. Greater than 2, less than negative 2. If you have any questions on this, I will wait for a second so you can tell me. Any questions on this? Why I need it? is because this is what I'm given. I'm told the first derivative is positive here, and the first derivative is negative to the right of 2, to the left of negative 2. Is this clear?
Yes.
Okay, thank you. So the first derivative positive between negative 2 and 2. Negative, so this is done. The first derivative is negative to the right of 2 and to the left of negative 2. And now it's all done. I put everything in the table, including the odd and everything else. So let's get it started. I'm told that this function has a horizontal asymptote to positive infinity, which is 1. But because the function is odd, they're not telling us, but it has to have y equals negative 1 at the other end. Because what I graph here, I have to graph here. Then, I am told that the function is decreasing till negative 2 and decreasing from 2 on. It's increasing between negative 2 and 2. Okay? So from approaching negative 1 will be, so negative 2 is here and 2 is here. So at negative 2 the function is from negative 1 to whatever, I don't know, I have to pick, is decreasing. And these have to be opposite. Okay. We're going to check everything in a minute. So it's decreasing, but it has a horizontal asymptote, so it has to be something like this. Then here it has a minimum, and then it starts increasing at between 0 and 3. The function is concave down, and here the function is concave up. So on the other side it has to be the opposite, so it has to be concave down and then concave up because of the symmetry. Okay, so I'm at negative 2, and now it opens up, it increases till I don't have any inflection points. I mean, I do. It's going to be at 0. Yes. Okay, I got it. So at 0, this has to be an inflection point because it changes concavity from opening up to opening down. So 0 is the key for symmetry. So it's increasing and opening up. Okay, got it. Now I don't need the table, I have to copy all this on this side. So opening up between negative 2 and 0, opening down between, okay. I forgot about 3. Three is the inflection point. And -3. So it goes to a maximum, and it continues past the 2, and it's at 3. It has an inflection point right here, inflection point. Here is a local min. It happens to be also absolute. And here it has a local max, and it happens to be absolute max as well. Very interesting problem you picked, Derek. Very good. Twisted. It had a twist to it. Okay. Good problem. We have time. I would like to look at one more. You can choose. You would like to see something else with a square root this time. I'm looking at this 39, but we don't have to choose it. Everything, all the same questions for function 39. The square, it has a square root, or if you want something else. Yes, Reese, you want 39 or something else?
I didn't say anything.
You didn't say anything, sorry. So anyone? You?
39 is fine.
Okay, so let's take a look at 39, since we haven't looked at a square root function so far. So this was 11, now this is 12. So please look at both the lectures, because with all these functions it's a lot of work. So 39. So we have f of x, x, the square root of 6 minus x. I can put this book away. Okay. So we're asked everything the same, domain, first derivative, anything that we learned from the first derivative, second derivative, and the whole thing. So I do have to start with the domain. So what do I